All right. So last time we looked at a very famous cipher, which is known as Caesar cipher. So this time we're going to look at another type of a cipher, which involves actually, let's call that a multiplicative cipher. So if you remember from Caesar cipher, it was actually multiplying your key and taking a mod. Here we're going to do in Caesar cipher, it was actually adding it and then you're subtracting it to decrypt your message. Here we're going to do multiplication with the key, but in this, if you recall from my previous videos, we're going to take a multiplicative inverse of your key. So we're going to take multiplicative inverses of your key. So if you remember, if you want to find out a multiplicative inverse, so the criteria that you need to remember, you can look at my video. If a GCD of two numbers is 1, then means both of these numbers are relative primes. If they are relative prime, then we know for sure there is an existence of multiplicative inverse. All right, I hope you got it. So that's the criteria, and the way we normally check this is A times B congruent 1 mod n. That's the criteria to check and see if that is multiplicative inverse or not. So you can look at the video on multiplicative inverse. So I'm going to choose a key. So let's say I'm choosing a key. So my key that I have chosen is to be 7. Why am I choosing this key to be 7? Because when I take a GCD of 7 and 26, I will get GCD to be 1. So you can look at my video on how to find GCD. And once I do that, I can use extended Euclidean algorithm to find out what is going to be my multiplicative inverse of that key. Because if the GCD of two numbers is 1, then definitely for sure I know there is an existence of multiplicative inverse. And here the multiplicative inverse that we're looking for is actually for that key, because there is no division. It's just there's mod operation, there's multiplicative inverse. That's why with key there is -1 in front of it. It does not mean that this is going to be 1 over 7. No, in cryptography, key inverse does not mean that I would take a cipher-text multiplied by 1 over 7, because we're working in positive integers. Cryptography only works for positive integers. So it actually means that you need to find the multiplicative inverse of that key in that domain. In our scenario, that domain is 26. Okay, so I'm not gonna go ahead and calculate and waste your time. I'm just gonna show you how it's done. So you can also look at my video. I'll just leave it at the end of the video, how to do multiplicative inverse and GCD. But I can check this criteria. So in multiplicative inverse, what is it that I'm looking for? Is that if you have found your multiplicative inverse of a number, what do? You multiply that by that multiplicative inverse which you have found using extended Euclidean algorithm and take a mod with 26. If you get an answer 1, if you get your answer to be 1, then you know for sure this is one of the multiplicative inverse. All right, so because I already know key, I'm going to do brute force attack. So here's my thing. I'm gonna take key is my 7. I'm gonna multiply this by 21 just for the heck of it, and I'm gonna check and see 1 mod 26. 7 times 3 is going to be 21. 21 mod 26, I'll get the same thing back. So I just keep trying different values of that. So I think when I do this, let's do this real quick. Let's try to find out what is multiplicative inverse. 26, 7. Let's quickly do it. Then we have remainder. This is going to be my remainder. All right, this is our A and B, and if you recall this, this is going to be your T1, T2, where T1 and T2 values are T4 value, and T is going to be T1 multiplied by Q multiplied by T2. I think it was something like this. Okay, so this is how you actually find multiplicative inverses of that of particular number using extended Euclidean algorithm, just to check and see if that GCD is true. So 7 times what gives me 26? 7 times 3 would give me 21. 26 minus 21 would give me 5. I have 7 and I have 5. 5 ones are 5. 5 times 1 is 5, so I get a remainder of 2. I get 5 and 2. 2 2s are 4. I'll get 1. 2 times 1. 1 2s are 2. And I'll get 1 and 0. You can look at my video on it. Alright, now I have to multiply Q2 times T2. So T2 multiplied by Q. So this is my quotient. So this multiplied by this, I'll get 3. And minus 1, so I'll get minus 3. I'll get 1 here. I'm bringing this down, negative 3. So negative 3 multiplied by Q, that is negative 3. Negative 3, and then I have a minus plus 1. So this is going to be 4. So negative 3 comes down here, 4 comes down here. So 4 times 2 is 8. Alright, 4 times 2 is 8. Minus T1. So T1 is negative 3. So negative 3 times 2 plus negative 3 minus 8 would give me negative 3 minus 8. 8, 10, 11, 10, 11, minus 11. So this is going to be 4 and this is going to be 11. And this 11 should be my multiplicative inverse. Okay, let's check. So when I get a multiplicative inverse, this T1 value to be negative 1, negative 11, which means I need to take a mod. So let's take mod of 26. So 11 mod 26 would give me the same thing because I'm going to treat this. You can also look at my modular tutorial. So now this is going to be, so I'm going to ignore the negative sign. So 11 mod 26 would give me 11. So 11, and I'm going to bring that negative out and I'm going to add 26 to it. So negative 11 plus 26, that should give me 15. So this negative 11 is actually 15. 15 should be my multiplicative inverse. Let's check and see using this criteria. So if I have 7, which is my actual key, times 15, congruent 1 mod 26. So let's multiply 7 times 15. Let's take our calculator. 7 times 15, 105, and let's take mod. I have already taught you how to do this. So 105 divided by 26, and let's do shift this 1. Yes, indeed it is, because the top number is 1. Indeed it is my multiplicative inverse. So the multiplicative inverse, the key inverse is actually 15. Okay, so the key inverse is 15. So let's quickly encrypt. So let's do encryption. Let's say I have a message which is hi. This is the message I want to encrypt. So my definition is going to be message, cipher-text is equals to message multiplied by K26. Okay, I'm going to refer to my code book because I also need code book here. So I know age, according to our code book, is actually 7. So I'm going to put this here. So CH. So this is going to be messages H. So the first message is H according to our code book. So we're going to make a small code book just like we did it in a previous video. So H is 7. So 7 multiplied by 3. K is 7, 26. So what is 7 times 7? Mod 26. So this is going to be mod 26. So according to our table, so 7 multiplied by 7, that is 49. So 49 divided by 26, and let's do shift and let's have it in proper fractions. That is 23. So age turns out to be 23. Let's do I. According to our code book, I has a value that we have assigned is actually 8. All right, so 8 multiplied by 7 mod 26. So 8 times 7 I think is 56. So let's do this. 8 multiplied by 7 divided by 26. So that should give me 28 over 13. So shift, convert that, and I'll get 2. So 56 All right, so I'm not going to take this word as is, because it's actually made it, it actually simplified it more, because my denominator should have 26. So let's do this. What is 27? So if I have 56, the way I'm going to do it is this: 56 divided by 26 would give me 2. So 2 times 26 would give me 52. All right, so 8 times 7 is 56. 56 mod 26. So 26 times 2 is 52. So, and I have 56 here. So 56 minus 2. So my remainder is actually 4. All right, I have 56 mod 26. So 26 times 2 would give me 52, and 56 minus 52 would give me 4. So this maps to, hold on a second, let me check and see. So this maps to 4. The value is 4. So according to our code book, 23 corresponds to X and 4 corresponds to E. So HI, according to our encryption, it's become XE. All right, so let's quickly decrypt this. So for decryption, message is equals to C times K inverse mod 26. So my message, sorry, yeah, I want to get my message back. So it's going to be X that I want to decrypt. So X is going to be, so my ciphertext is X. X is a value of 23. The key inverse is actually 15 and mod 26. All right, so let's quickly do it. 23 times 15, just quickly do it. 23 times 15 divided by 26 would give me shift this, that would give me 7. All right, 23 times 15 mod 26. 23 times 15 divided by 26, that would give me 7. All right, and let's quickly do the other one, E. So which is C times K inverse mod 26. According to our code book, our ciphertext, which was E has a value of 4. So 4 multiplied by 15. 15 is my multiplicative inverse mod 26. So 4 times, so let's quickly do it. 4 times 15 divided by 26 mod 26, that would give me 30 over 13. When I shift it, it's actually 4. So let's do it normally. Why? Because the denominator is changed. I don't want to go into details of that. 4 times 15 is actually 60. Let's divide 60 divided by 26. That would give me 2. So which means 26 times 2 would give me 52. So 52 minus 60 would give me 6. 15 times 4 is 60. 60 mod 26 would give me a value of 8 actually. This would give me a value of 8. 15 times 4 is 60. 60 mod 26 would give me 8. Why? Because 26 times 2 is 52. So 60 minus 52 would give me 8. And 8, according to my code book, is actually I. So this has become H, and this would become your I. So this is how you use multiplicative inverse. So this is still monoalphabetic. Same letter will map. So if I have 2, or if I have in my text, if I have 2 I's, it will map to the same ciphertext, which makes it easier if I perform frequency analysis to actually decrypt that. And same thing, it's a stream-based cipher, which means one letter at a time you're encrypting this message. So, but I kind of don't like this. Why? Because it's mono-alphabetic. You can easily do a frequency analysis attack on it, and it's a very tedious process. You have to do this to find the multiplicative inverse of it, and things like that, do GCD and things like that. So it's easier to use an additive cipher if you are into mono-alphabetic ciphers. But we will look at some polyalphabetic ciphers, which are much it's hard to do frequency analysis attacks on it. So I hope you like this small video on multiplicative inverse. Don't forget to subscribe to my channel. I'll leave video link at the end of the video of how to find multiplicative inverses and GCDs, even though I did it here, but you can clearly see what's going on. And don't forget to subscribe to my channel. If you have any questions, leave it in the comment section.